Would you still use ChatGPT if your boss could read every single prompt you typed in? In today's episode of Threat Talks Deep Dive, we discuss Comfort, a secure way to communicate with AI. Let's get on to it.
Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity.
With me today is Dirk Bell, a senior developer here at ON2IT. And my name is Rob Maas, field CTO. Dirk, welcome.
Thank you.
What was the last time you typed something into the AI, ChatGPT, for example, that you wouldn't share publicly?
Probably this morning.
Okay, quite recent. And
Yes.
I think that counts for most people. So that means that we share a lot of sensitive data with AI, and a lot of companies using it. For example, developers as yourself, you probably will use AI and send a lot of code into the prompt. What makes AI then so different than, for example, using Google or using your email in the cloud?
Well, the AI has, when you're using the AI, you add a lot more context than when you're using a simple Google search.
Mhm.
You just, when you're doing a Google search, you just enter keywords you're looking for. And when you're using an AI prompt, it automatically loads a lot more context. And AI has a memory of your previous prompts. When you're using Agentic AI, it has access to files that you have, and a lot of that data is included in prompts that go to the remote AI provider.
Yeah, because an LLM needs a lot of context to come up with a better answer.
Yes.
Do you think most people are aware that all that data is being sent to the AI, mostly remotely, and that those companies like OpenAI and Anthropic are able, if they want, to see all that data that's coming in and read their prompts? Do you think they are aware of that?
Well, it's such a rapid development with AI that I don't think everybody fully grasps how it works and how much data is actually being sent with every prompt.
Yeah, so we kind of automatically trust those providers that they would do us no harm.
Yes, and that's what they promised. On one hand, they say we will not expose any of your data. On the other hand, these companies need our data in order to improve their product.
Yes, yeah. So that's quite a contrary to each other, and that's basically means that we just trust them, which is not a
That's
very good
indeed.
security strategy.
They say, trust us, we will only use your data to improve our service.
Yeah, and that's kind of the opposite of what we normally predict: zero trust. So never trust, always verify. That's something we cannot do in the current state with ChatGPT or Claude.
No, because you type a prompt, and the prompt contains a lot of context, and all that data is just sent to the AI provider.
Okay.
And you trust them. Yeah.
Yeah, we already mentioned there's a lot of sensitive data being typed in by us as users, but it even gets worse now that we are going into the AI agents, I would say, stage of AI. Why is that?
That's because when you're using an agent, you enable the agent to access more context. Like as a developer, when I'm working on a file, the agent has access to all the files in my project, and it will decide what data is relevant, and it will include all that data and all the contents of all these files that it finds relevant, and send them to the AI provider.
Okay. Yes, that's normally I would copy paste things in a prompt, but I'm really in control with the AI agent. You say it's done automatically. It will decide for itself. Oh, these files look interesting. They seem to have
indeed.
context relevant.
Yep. When you're using the old way of having a chat with the AI, you say, hey, listen, I have a data set, and you carefully supply the data into the chat. You say, here's a CSV file with some data. Please consider this data. And when you're using an agent, it will say, hey, I see a data file. I'm going to include that one. It might be relevant.
Yeah. So, and you already mentioned the example of being a developer. I can also imagine, for example, if you're a salesperson, before that you could copy paste the relevant and the not sensitive information yourself. You were in control, but maybe now there's an agent that could automatically connect to your CRM system, gets the data out, and automatically send it to the AI, and maybe exposing a lot of customer data with
The
it.
MCP development really enables agents to autonomously query data sources. So it might say, I need access to the CRM system. Give me a list of clients, or give me access to your email or your calendar. And all that data could end up being part of a prompt and being sent.
And even maybe without you knowing it. So that's maybe done automatically by the agent, and you are not being aware of
Yes.
it. Yeah. Okay. So I think that defines the urge that we really need to come up with a solution for this. We can, well, if you have money enough, you can run AI locally, but that's really hard at the moment to do it at scale, at least. But luckily, we have Moxie Marling Spike, and some people might ring a bell. That name is also related to the Signal protocol, which is the protocol being used in the Signal messaging app, and also with different apps nowadays. So it's a really successful way of secure communication for those apps. And he came up with a solution which is called Confer. And you can look it up at confer.to. But before we dive into the technical details of Confer, you came up with a very good analogy. What we actually tried to solve, and that analogy was around the employee survey. Can you explain that to us?
Yes. So here at ON2IT, we have our yearly employee survey, which is sent out by the HR department. Everybody receives an email that says, hey, do you want to take part in the survey? Click the link, fill in the survey, and we will anonymously process your data to calculate averages.
Yeah, and this is how you say it now. I think that's important. Now you tell it to me like it's kind of, trust me, I'm going to anonymously process this.
We put trust in this process and in this mechanism, because HR department tells us this is how we are handling your data, but there's no guarantee in that.
I cannot check it, at least not.
You cannot verify that indeed the data is and always will be processed anonymously. You have to trust that that's how it will be handled.
If I want to make sure that all the data is being processed anonymously, what would the process be around it? How would we get to that result?
Well, if we look at the survey, let's take one question that says, rate your boss.
Mm-hmm.
I want to be able to verify that whatever rating I put in, that these ratings of all the employees are only going to be used to calculate an average. So I want to verify that how will they calculate the average, and is that the correct way, and is it just using my not using my name? So it needs to be done anonymously. I want to have a guarantee of that. So I want to have an insight in how they are going to process the data that I submit.
Okay, and what would be a solution for this?
A solution would be, let's say that there's a calculator in a box, and the box has a lock, and every employee gets a slip where they can write down a score, and it's you put your slip into the box, and you can see the wires in the box, and you can verify that the way it's wired, it will just calculate the average of all the numbers that have been entered. And after a certain amount of time, it will output an average, and then all the data is destroyed. It will self-destruct or something like that.
Yeah. Okay. But as you mentioned, it is important to have some rules around it, of course, so that it does not calculate the average when you put in the first person, your rating, because then we still can say, okay, but this was Dirk. That was the last person who entered the score or the rating. That was an important, I think. And the second one was you should have set the end date when you open the box and when everything will be destroyed.
Yes.
So there are some rules, and you need to be able to verify that. And you said that, okay, but if I'm able to check all the wiring, then I should be able to verify that part, that everything is working as expected. That's more or less what's happening with Confer as well. So if you replace the survey with an AI conversation, then you can replace the box with Confer more or less. So now let's go into the technical part, and it's quite some steps and quite technical. And we have an infographic. So if you're reading along or you're sitting behind the screen, make sure to get that infographic so you can follow along what's exactly happening here, because we go quite deep technical. Let's start. How does Confer work? I go to confer.to on my web browser, and then what happens?
So what happens first is we need to have this box. So on the Confer systems, a trusted execution environment is created. And a trusted execution environment is an isolated program, you can say. So
It's kind of the box that runs everything.
it's isolated from the rest of the computer. So it will run a particular program, and the program needs some memory, and the vendor of the processor or the creator of the trusted execution environment guarantees that the box will run only one program.
Okay, and with the vendor you mean the hardware vendor. So for example, Intel.
Yes. So Intel builds processors that are capable of creating trusted execution environments, and Intel will then guarantee the same. Once you load a program into the execution environment, it cannot be modified, and every memory that's being used by this program is encrypted and only available to the program. So you create an isolated execution.
Okay. So that's the first step. I connect to confer.to with the web browser. It will spin or create this box. And then what happens next? It spun up everything.
Yeah, what happens next is Confer says, okay, we created a isolated environment and we're going to run a program. And this is the fingerprint of the program we're running.
Yeah, it will send that back to me.
Send that back to the user. And what we as user can then do is we can go to GitHub, and they actually... you can look at the source code of the program that is running, and we can verify that this program will handle our prompt, and it will not store our prompt anywhere. It will not do anything other than answer our prompt.
Okay, so this is the equivalent of checking the wires in your previous example.
This is the same as making sure that all the numbers are only used to calculate an average. We can look at the Confer source code and say, oh, this program only ever answers our prompt and it does nothing else with the data.
Okay, so and then let's say I have checked everything because I really want to make sure that all the wires are connected correctly. Now I need a way to securely send my prompt messages to that trusted execution environment.
And this is part of the program that's being loaded in the execution environment. What it will do is it will create a noise channel, which is the same as starting a chat in Signal. So it uses the same protocol to set up a secure, encrypted, one-on-one conversation. So from that point on, you know that there's this box running on the remote system. I know exactly what software is on it, and I know that there's a secure one-on-one communication line between me and the remote party.
Okay, so now I can send my prompts securely to this trusted execution environment, the box.
Yes.
And it will only be decrypted within that box, which I completely verified what the program is running and what's happening with my data.
I know you know exactly what the remote party will do with your data and will only answer the prompt. And the hardware that it's running on guarantees that the memory used will only be accessible by that program. So my prompt is secure, encrypted, and isolated, and only available to that specific running instance.
Okay. Okay. So I go back and forth a bit with this. Well, let's call it a session with the trusted execution environment. I go back and forth with my prompt. Now I'm done. What's happening? What's the last step? So I close my session. I have my answers. How do I make sure that the data is not anymore on that machine of the remote party?
So when you end your session, all the encryption keys were bound to that specific session and only exist in memory, which is encrypted and bound to the particular trusted execution environment. So once it stops, everything just disappears from memory.
You throw away the keys.
You throw away the keys, and that's it.
Yeah, and even if you would be able to make a snapshot of the memory, you cannot easily move that to different hardware because it is tied to the hardware.
Yes, that's part of the execution environment itself. It's the encryption is done by the hardware, so it's a hardware locked encryption key that encrypts the memory bound to the TEE. So even if you would have full control over the hardware, you would make a snapshot. You cannot make a snapshot of the hardware key.
This means that even employees of Comfort, for example, can never access your data. It's encrypted. Exactly. They cannot make a snapshot even and move it away.
You would take a raw copy of the memory. It's still encrypted memory, encrypted with a key that was bound to that particular
hardware.
Yeah.
Okay. So this sounds really like a good solution to me. We can verify everything you explained. We can verify that the program is actually doing that by going to the source code if we really want to check all the wires. Everything is encrypted, so also man-in-the-middle attacks, those kind of things are really hard to execute. What kind of people or what audiences should be looking in those kind of solutions like Comfort? Can you give some examples?
Yeah, I think, well, my own field for development, it's when we work on trade secrets or sensitive pieces of software with Agentic AI, parts of our code is being sent to a remote party, and we want that to remain secret.
Yeah, it's the intellectual property of the company.
Intellectual property. You can imagine a CISA working on a vulnerability report or maybe even a long-term marketing strategy for a company should remain secret.
Yeah, I think also maybe if you're bound to regulations, like for example in the European Union we have GDPR, and we already saw that some companies used ChatGPT with customer data, and if too much sensitive data is being sent to, for example, ChatGPT or Claude, then it counts like as a data leak because we cannot guarantee what happens with that data once we have sent it to for those providers. So for those, mainly also a CISA role, it's also really interesting to look at these kind of solutions. Okay, so we're almost at the end here, but Signal is a very big success. It's being used in almost every messaging platform nowadays. Do you think the same will happen with Comfort? Will, for example, Claude or Anthropic or OpenAI adopt this technology?
Yes, I think they should. And the reason is that more and more, we're using AI more and more, and it's more and more becoming a piece of critical infrastructure for us. And more sensitive data is being put into prompts. And yeah, the part of everything is needed for training data is over these days. We need to be able to have verifiable trust in that our data is not going to end up everywhere.
Okay. Well, that sounds like something then that hopefully is coming for everyone of us. Thank you. Let's wrap it up. So I think we have seen that privacy and powerful AI can coexist. It doesn't have to be a trade-off. Comfort shows us that it can be done. And I think we all know that trust, what we currently use, is not a very good security strategy. So with that, thank you, Derek. Thank you, listeners, for listening in. If you want to try Comfort for yourself, you can go to comfort.to, which you can run for free and try it out and see how everything works. And if you want to see every step that's happening, then download our infographics. You will find it with the show notes. Thanks again for listening in, and I hope to see you next time.
Thank you for listening to Threat Talks, a podcast by ON2IT Cybersecurity and M6. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.